Hello everyone, today I will demonstrate how you can use soft core logic analyzer in Quartus. In fact, you can use that for any Altera, FPGA or SoC. So first let's go for design. So I have the clock input, key input and LED output. I'm registering the keys to detect if the key is pressed. If key 0 is pressed, then I'm incrementing the counter. If key 1 is pressed, I'm clearing the counter. And then all the time I'm assigning the value of counter to LED. So before we go to logic analyzer phase, first you can guys always verify if your design is what the compiler understood. So you can go through analysis and synthesis, then netlist viewer, and then RTL viewer. So you can double click that and you see this is design I actually wrote. So I have registers for keys. If the key 0 is pressed, I'm selecting lower part of the multiplexer that is +1 to the value of this register. If this is 0, then whatever was before it is propagated after this MUX. And this second MUX is for resetting. If key 1 is pressed, you see these ones there. So if key 1 is pressed, it simply sends 0 to this register. That's pretty much what I designed. So after you do this compilation, then you can proceed. So after compile design is complete, then you can proceed to tools and then signal tap analyzer. First thing you do here is you have to understand what these tabs are useful for. So this tab here is to open your design and then program FPGA. So you can program FPGA from there also. So you can click there, select the compiled design, and then if you click this, it will program the device with your design. But before we do that, first we have to configure the signals for our analysis. Obviously, first thing we have to check or we have to select is the clock. On which clock the data will be triggered. So I press this here and I press list and I have to select the clock. So this is the clock signal, so I will send it there. In fact, this is more like ugly view of those signals. So I usually prefer to select these pins all and registers post fitting. I think that is the one. So it gives me the clock signal as in like correct name. Then we can click yes there, and then we have this is red, but I think it should not be a problem. So then we select what is the depth of signal, depth of the values. So we select there what is the depth of the memory for each signal. So if we select 512, that's more memory will be dedicated for each signal. So 512 samples of those data will be stored into this memory. Next thing is you select the signals itself, which you want to observe. So again, we'll select my signals, which is more readable for me. So count is what I'm interested in, and key reg is what I want to check. And that's pretty much all. First, until you proceed, you have to select the triggers. So on what triggers are like, on what condition should the sampling start. So here I will select if key 1 is pressed. So here I will click key or key 0. So if key 0 is pressed, so you right click there, and in my case key 0 is giving me 1 when it is not pressed. So if I select falling edge, it will trigger this sampling when I press the button. So I will trigger it on this, and I will trigger it on that also. And I will select here OR. So if either of those will happen, it should trigger the sampling. Okay. So rest, some parts of it are good to know, but you will find out these parts by yourself. So after this, you have to recompile your design. So obviously, press this, press save, and let's save it there, and then let's enable it for this project. And after this, we wait for a couple of minutes. Usually it takes a little bit longer with tap analysis than without tap analysis. So the recompile is complete. I'm pretty sure it took at least like 40 seconds more than before, but you can check it on video how much more it was. So then I will click here again, and then I have to program my FPGA from here. So I click that, and my device is being programmed right now. So now we can check if everything is okay. So for that, I will click outrun or run analysis. So outrun, I think it's happening once. So I click that. Now acquisition is in progress. So I will press key 0 right now, and we can observe what actually happened. So I will click here to zoom. And by the way, notice that this is 0 time, and after this we can say like 512 samples actually happened but this 512 is from 0 to this value, and some values were also saved before the 0. So what's actually happening there is it's always sampling the data, but it provides us with the values here that started with this minus something percent of time, and the rest of it after the trigger. So let's zoom it there and let's observe. So actually it would be nice if I had added the clock signal there, but I don't have it, but still it makes some sense. So when I pressed Q1, so key 0, sorry. So when I pressed key 0, it was 1 before, now it became 0, and after some time, so that means on the positive edge of the clock, our counter got incremented. So if I press it again, let's say a couple of times, you see the counter is incrementing. So now it's 12 in hexadecimal. Here you see it there, like that. So if I can expand it, it's more visible to see how binary values are changing. So anyway, this works in real time. So in real time, it's sampling those data and giving them to me on this waveform. So it's pretty similar to what simulations look like, but it's from the real FPGA board. So if you have a mistake in your design, that will definitely show up there. Of course, if you add them in your monitoring list. So if you press Q1 here, counter is reset, and you see it was 27 in hexadecimal, and now after the press it became 0. So now it's 0. So far so cool. That's all for signal analysis. And there was a way to disable this signal tap analysis. I think it's somewhere. Let me check that. It's somewhere here, but I'm not sure. So yeah, I found it. So you have to go to compile, then analysis, and then edit settings, and signal tap logic analyzer, and you can click that and click OK. So before it was 1 minute and 36 seconds, and now if you recompile it again, it will recompile without signal tap analysis, so it should be faster. So after I disabled it, from 1 minute and 36 seconds it went down to 32 seconds. So that's how much signal type analyzer is adding to the compile time. But again, it's very useful to debug your design, because sometimes you can't really simulate some things you are interacting with. So it's very cool feature.